All right, so in this video, we're going to be going over some of the problems associated with water saving. So the calculations, how do we figure out how much actual water savings and monetary savings a customer can achieve, given rebate circumstances, programs like that. So the first one we're going to start off here is really about just calculating money saved. So let's just say if a customer determines they can make habit changes, upgrade devices, whatever it may be. Let's say they can determine that they can save 120,500 gallons in a year. All right, this is how much money they can save in that particular year. What we want to look at then is, okay, if this is how much water they're saving, how much are they paying for this, and where is this coming from? So we're just going to say that the customer on averages pays $3.35 per every CCF, or every 100 cubic feet. So given the cost of the water, given the amount of water saved, now we can determine, okay, how much money is this customer going to actually save per year? So in this particular case, we need to bring our units the same. We either need to go from gallon to cubic feet, or we need to go from 100 cubic feet back to gallons. I recommend converting gallons to 100 cubic feet. It makes it easy to figure out the cost. So let's do a simple unit conversion. So 120,500 gallons. Well, we set up our conversion factor. We're trying to get rid of gallons. It's going to go on the bottom. That's what we're getting rid of. And up top, we want to bring in our cubic feet. We know that there are 7.48 gallons for every 1 cubic foot. We can take this one step further, and we can say that, well, we need to get into CCF, which is 100 cubic feet. Well, we know that there are 100 cubic feet in 1 CCF. So what do we do now? We grab our handy dandy calculator. We do 120,500 divided by 7.48 divided by 100, and we get to 161.09. So we'll just say 161.1 CCF, or 100 cubic feet. Now to figure out how much money the customer is going to save, we're going to take our volume of water saved. We're now going to multiply by this cost, this $3.35 per every 1 CCF. This gets us to cancel out CCF. We're going to be left with money. So I take 161.1, we'll keep that 0.1, why not, times $3.35. And I, as a customer, am going to save a total of $539.68. That's how much money I'm going to save based on total water saving parameters and the cost for that water. Now, the next problem I want to do gets a little more specific, right? It gets to, well, how did we calculate the number of gallons that we're saving, right? Then we can figure out price. So let's look at an example where we are switching out our grass. So in this problem here, we're trying to figure out how much water we can save a year by switching from obviously thirsty grass to a low water landscape. So the landscape in question here is 1,800 square feet. It's currently all cool season grass. This grass requires 4.5 feet of water per year to be happy and healthy. This is normal for here in Southern California. We are given an irrigation system that is 60% efficient, right? And this is normal for spray systems. Spray irrigation, remember, is very inefficient. We're misting the air, we're watering the sidewalk, we're dribbling onto the grass, we're overwatering dramatically. So here's our given parameters. Now, how much water can we save if we take this same landscape and we switch to a California native landscape, or mostly native landscape, that requires 16 inches of water per year to be happy and healthy? We're switching our system from spray to drip. We're now watering it at 90% efficiency as well. Right? Drip, remember, point source water is being put right to the surface of the soil, right where we want it, right where that plant needs it. So here's our parameters. We've got 1,800 square feet still. We're going to get rid of this, and we're going to install this. So what we need to do is we need to calculate the total amount of water used in this landscape and the total amount of water used in that landscape. The difference is going to tell us the amount of water that we're saving. So let's start with the grass here. Now, the first part we need to tackle, which isn't directly intuitive, is that we need 4.5 feet of water, but it's only 60% efficient. So what we need to figure out here is we are saying that 60% of the water applied is actually making it to the soil. So we're losing 40% essentially. So the way we can calculate that is saying that 60% over 100, basically how do we figure out the 4.5 feet of water that's required over the actual amount I have to apply? So the way to think of this is I have to apply more in order to achieve 4.5 feet. So in other words, I'm saying 4.5 is 60% of what total number? That's my goal here. So what we're going to do is we're going to cross multiply. So we're going to say 60x is equal to 450. So we're going to pull out our calculator. We're going to go 450 divided by 60, and we get to x equaling 7.5 feet of water. That's how much actual water we're going to have to apply to water. So now we can go take that 7.5, and that's the actual amount of water here, right? So 7.5 feet is how much we're going to require here. Now, let's do the same thing again for our second system here, right? Because this is our total water used. So same thing again. Let's go ahead and convert this to feet. Right, so remember we can always do 16 divided by 12 because there are 12 inches in a foot. So we'll say that this landscape is 90% efficient for watering, same way we set it up last time. I end up with 1.33 feet of water. That's how much I need, 1.33 feet of water. Divided by what total amount, right? Because remember, 90% of what number gives us that 1.33? Because we are going to lose, say, 10% in this scenario here. So again, we cross multiply here. We end up with 90x equaling 133. When we take 133 divided by 90, we get 1.477777. So we're going to say 1.48 feet of water is going to have to be applied to this landscape, right? So that replaces our 16 inches at 90% efficiency, and that says we are applying 1.48 feet. Now, without getting, quantitative, just qualitatively looking at these numbers, you can see, wow, this is way more, this is way less. Obviously, there's going to be huge savings when we amplify that over this volume here, but let's go ahead and do that. So let's calculate our grass, figure out our total water use. So if we've got, and this should say square feet, if we've got 1,800 square feet, we're going to multiply by the total water applied, 7.5 feet. Pull out our handy dandy calculator, 1,800 times 7.5. That gets me to 13,500, again, follow your units, cubic feet. Right? Now, most of the time when we're talking to customers, we talk about money saved, gallons saved, water saved, we need to be thinking in gallons. Customers don't really accumulate, think about cubic feet, for example. We want to talk about gallons because they got a gallon of milk in their fridge, right? So we've got 13,500 cubic feet of water used on this landscape this year. Let's calculate our second landscape here. We've still got the 1,800 square feet, 1.48 feet of water being applied. So 1,800 times 1.48 gives us 2,664 cubic feet. Now I'm going to take the 1,300, 500, I'm going to take that and I'm going to subtract off the difference, 2,664 cubic feet. So 13,500 minus 2,664, that gives me water savings of 10,836 cubic feet. Remember, I can take that cubic feet, multiply by 7.48 to give me total water savings of 81,053 gallons of water saved per year, right? So if we now then we as a person working with a customer, we can take the gallon amount and say, well, here's how much you're paying, here's how much actual money you're going to save, right? Keeping in mind that most rate structures, especially here in Southern California, are on a tiered basis. So water in your lower tiers is made for indoor use, it's cheaper. The second tier is usually outdoor use, it's a little more expensive, but when you go above that, when you exceed your budget, water becomes exponentially more expensive. So in the last example, we saw a savings of 500 something dollars. Well, if you're exceeding your budget, you're paying more and more, or in a drought, you may be getting hit with fines. That dollar amount saved may be even greater, maybe even more significant. And another thing to consider that this problem doesn't address immediately is, well, how much rain are we getting, right? Well, if we're getting 10 inches of rain, right? Well, the water we are applying to this landscape, we can subtract that off from the amount of water that those plants need. So now we may only need to apply, say, 0.6 feet of water instead because of how much rain we're getting. Now, of course, the same goes for our grass. The difference is that oftentimes when we have rain and we have grass and we get rain, we oftentimes don't cut our sprinkler system as long as we could or as long as we should. A lot of times with grass, we've got really depleted soils. They don't hold water very well. They're compacted, as opposed to a lot of our soils once they've had our natives and we've added and amended them correctly, right, with, remember, compost into the soil, mulch on top, we're going to hold a lot more of this water as well. So the water use for this low water landscape requires this many gallons. That doesn't mean we're applying that many gallons via irrigation. So another thing to keep in mind with this type of problem. So the last problem here I want to cover when we are looking at water efficiency and calculating water savings is more from an indoor perspective. So the next problem we're looking at is a hotel. Okay, we have a hotel built in 1988 that's got 340 rooms. Okay, so good size, right? It's not any Vegas size, but it's a good size hotel. Now, being built in this time, each room has one bathroom. We're assuming we're not looking at suites or double rooms or anything like that. Every room has one bathroom, and in this bathroom, there's a shower head that's rated at 4.0 gallons per minute. So what we want to do is we want to look at if this hotel switches out these shower heads to a low flow shower head from 4 to 0.25, or we'll say 0.5 GPM, what kind of water savings is this hotel going to see over the course of, say, a year? All right, so given 340 rooms, we know these aren't full all the time, and depending how many people, there's a lot of factors. So what we're going to assume here is that the hotel has a 75% fill rate. We're just going to assume that throughout the entire year. And we're going to assume that each one of these showers gets used for 25 minutes a day, right? This could be one person showering for 25 minutes. You throw a family of 4, shower's going to be a lot longer than 25. So this is just an assumption we're using, right? We have to assume something in order to calculate this. So let's figure out how much water are they going to use at the 4 gallon per minute rate through a year, and how much water are they going to use at the half gallon per minute rate. Subtract the 2 is going to give us a total water saving. So let's start with the rooms. We have 340 rooms. That tells us we have 340 shower heads, but we're only at 75% capacity, right? So 7.75 times the 340 is going to tell us this is how many rooms are actually being used, right? Then we assume that each one of these rooms has a shower head that uses 4 gallons per minute. We're going to assume that we are showering for 25 minutes per day, right? So what does this tell us? This tells us the number of rooms that are actually occupied. This incorporates the flow rate of the shower head, and this incorporates the minutes that we're showering in that given time period, in that given day, right? So then what we want to do is we want to take it one step further and multiply by 365 days in a year in order to calculate our yearly water savings. So 340 times 0.75 times 4 times 25 times 365, and that gets me 930,750 gallons a year. So 9.3 million gallons per year. Then what we're going to do is we're going to run the same numbers, the same scenario. Instead of 4 gallons per minute, we're switching them all out to 0.5 gallon per minute shower heads in this case, right? So we'll run the same numbers. Instead of 4, we are going to say 0.5, and we end up with 1163437.5. 1.1 million gallons per year water. So now I'm going to take the difference between these two. So the 9307500 minus the 1163437, and that is going to give me, what happened here? I got to start over. I don't know what happened here. 9307500 minus 1163437.5. Always double check your numbers in your calculator. What does that give us? 8,144,062.5 gallons of water saved per year. Now remember, this was a very old hotel, hadn't done any upgrades, so very high flow shower rates, and they switched to very low flow shower heads. But with the technology that we've got, 0.5 can actually feel like a good shower. When a lot of times when we first come up with these water efficient devices, the technology isn't there. We kind of just cut the flow and have everything the same. Well, the toilets didn't flush very good. The shower didn't feel very good, but technology has improved a lot to where low flow toilets flush a lot better now than they did 10, 15 years ago. The same with shower heads. So if you get some good quality shower heads, that's pretty significant. Now, if you're the hotel owner, you're saying, wow, I'm going to save 8 million gallons a year. How much am I paying for that water? And then you can calculate a cost savings and say, hey, you're going to save X amount of money per year. That helps to pay off the investment, right, of buying the shower heads, the labor to change out the shower heads. Then you look at that over time and say, here's how long it's going to take to see your return on your investment, right, to pay for the shower heads. Any year after that, now you're saving money, which means you're making money, right? The more you save, the more you make. Okay, so those are 3 various types of problems for calculating the amount of money saved given water savings, calculating outdoor water savings, and also calculating one version of indoor water savings.